Let me start with the basics. What does this repository do, and who would find it useful?
Scroll World is a tool that generates immersive, scroll-scrubbed 3D world landing pages for brands or industries. It allows users to create a continuous, seamless, fly-through-the-world experience where the camera moves from scene to scene as the user scrolls, with no cuts or interruptions. It's designed for developers and designers who want to build visually engaging, interactive landing pages that feel like a continuous journey through a virtual world.
That sounds impressive. What makes this kind of experience possible, and what was hard or impossible before this tool existed?
Before this tool, creating such an experience would have required a lot of manual work and specialized tools. Developers would have had to build custom 3D scenes, animate transitions between them, and synchronize the scroll position with the camera movement. This would involve complex 3D rendering, animation, and interactivity code. Scroll World simplifies this process by automating the generation of the scenes, the camera flights, and the scroll scrub transitions between them.
I see. So the tool is making things that were once quite complex much easier to implement. What are the key components that make this tool work?
The tool is built around a few key components. First, it uses AI to generate the isometric diorama scenes and camera flights. These are rendered using AI image and video generation tools like Higgsfield or Codex's Image Gen. Second, it uses a scroll-scrubbed engine that maps the scroll position to the camera movement, allowing for a smooth, continuous experience. Third, it includes a portable Vanilla.js scrub engine that can be integrated into any HTML-based project without relying on a specific framework or library.
That's interesting. I'm curious about the technical implementation. What are some of the more intriguing or complex parts of the codebase?
One of the most interesting parts is the scroll-scrubbed camera flight engine, which is implemented in the scrubengine.js file. This engine is framework agnostic, meaning it can be used in plain HTML, Next.js, Vue, or even Python-served pages. It dynamically builds its own DOM and injects its own CSS into a container, allowing it to drop into any project without requiring significant modifications to the existing codebase.
That's a neat feature. How does it handle the synchronization between the scroll position and the camera movement?
The synchronization is handled by mapping the scroll position to the camera's position in the 3D world. As the user scrolls, the scroll position is used to calculate the camera's movement, ensuring that the camera moves smoothly from one scene to the next. This is done through a combination of JavaScript event listeners and CSS transitions, which allow for a seamless and continuous experience.
What about the AI-generated content? How does the tool use AI to create the scenes and camera flights?
The AI-generated content is handled using two main tools, Higgsfield and Codex's Image Gen. These tools are used to generate the isometric diorama scenes and the camera flights. The scenes are generated based on the user's input, such as the brand name, industry, and pitch. The camera flights are then generated using Seedant's image-to-video tools, which are provided by Monad. These tools are used to create the seamless transitions between scenes.
That's fascinating. I'm curious about the fallback options. What happens if the AI tools aren't available or aren't working as expected?
In the event that the AI tools are not available or not working as expected, the tool has fallback options in place. For example, if Higgsfield is not available, the tool can use the Cling30 model from Higgsfield as a fallback. This ensures that the tool can still generate the necessary content, even if the primary AI tools are not functioning. This is handled through a fallback logic in the code that checks the availability of the AI tools and switches to the fallback options if needed.
That's a smart approach. What about the mobile version of the landing page? How is that handled?
The mobile version is handled by rendering a parallel portrait chain, which is optimized for mobile devices. This version is rendered in 9:16 portrait format and is composed for phones rather than being a crop of the landscape film. This ensures that the mobile version is optimized for viewing on smaller screens and provides a seamless experience on mobile devices.
That's a great feature for ensuring a good user experience on mobile. What about the user interface for the tool itself? How does the user interact with it?
The user interacts with the tool through a series of prompts and options. When the tool is invoked, it interviews the user to gather information about the brand, industry, and the desired scenes. It then generates the assets based on this information, including the stills, the dive-in camera clips, and the connector clips. The user can also opt in to the mobile version, which renders a parallel portrait chain. The tool provides a user interface that allows the user to review and approve the generated content before it's finalized.
That sounds like a lot of automation. What about the cost and the billing model for using the tool?
The tool uses a pay-per-use billing model. The default video chain backend is modded, which is billed per clip in USD. If modded is not available, the tool uses Higgsfield credits as a fallback. Additionally, if the codec CLI is available, the tool can use codex's built-in image gen, which is billed to a ChatGPT subscription instead of Higgsfield credits. The tool provides estimates of the cost before generating any content, allowing the user to approve the budget before proceeding.
That's an important consideration for users. Are there any limitations or potential issues that users should be aware of?
One limitation is that the tool relies on external services such as Monet and Higgsfield, which may have their own limitations or costs. Additionally, the tool requires certain dependencies such as FFmpeg, ffprobe, and Python with Pillow. These dependencies may need to be installed separately, which could be a barrier for some users. Another potential issue is that the AI-generated content may not always match the user's expectations, and adjustments may be needed to achieve the desired result.
That's a good point. What about the technical requirements for the tool to function properly?
The tool requires several technical dependencies to function properly. It needs the modded CLI with an API key and balance, the Higgsfield CLI with credits, FFmpeg and ffprobe for frame extraction and encoding, Python 3 with Pillow for the mobile portrait canvases, and optionally the codec CLI for image generation. These dependencies are necessary for the AI-generated content, the video rendering, and the mobile optimization, respectively.
It seems like the tool is quite dependent on a variety of external services and tools. How does the tool ensure compatibility and stability across different platforms and environments?
This repository is ideal for developers and designers who are looking to create immersive, scroll-scrubbed 3D world landing pages. It's particularly useful for those who want to build visually engaging, interactive landing pages that provide a seamless and continuous experience. If you're interested in creating a unique and engaging user experience for your brand or project, this tool is definitely worth exploring.